So now that we've done disc, we're going to move on to doing washers, and it's kind of a similar process. It's just that now our shapes have a hole in the middle. So like I said, it's very similar to what we're doing. I just want to do a couple of examples. The first one, almost exactly like the one we did in the last video, is we're going to have y equals the square root of x, the x-axis, x equals 2, and x equals 4. Only now we're going to revolve this around the line y equals -1. So same thing as last time, we're going to draw this area first, which we already know what the area looks like because we had it last time. So it was the square root of x, so from x equals 2 to x equals 4. So there's our picture. We want to revolve this around y equals -1. So kind of pretend like the y equals -1 is a mirror, and then just flip this picture across it, and then connect all the endpoints. So we're kind of imagining what this would look like. So maybe I'll draw it off to the side if you can't tell. In the top, make this little hole in the bottom, and then we have another hole, kind of goes all the way through it. So it looks like a bowl, a solid bowl, that has a hole taken out of it. That's the picture that we're looking at. So what we're going to do, just like we did last time, we are going to take a slice. So take a slice right here, and imagine pulling that out of this shape. Now when we pull it out though, it's a washer instead of a disc. So it's not solid, it has that hole in the middle. And to find the volume of our slice, it's still going to be the area times the depth. But now the area is going to be that pi times big R squared minus pi little r squared, and then times that little bit of depth. So this is doing the big disk, and then we're going to subtract that little hole. That's what we're doing. So let's just kind of work through this. For the big radius, so go back up to my picture here, and I'll put it in a different color so you can see it. So how about purple? So the big radius is being measured from this line here at y equals -1 all the way up to the curve. That's that big radius. And that big radius is the curve, but the curve only goes to the x-axis, and then +1. So this distance was square root of x. This distance is 1. I know it's y equals -1, but the distance is 1. So my big R is square root of x plus 1. And we're going to be squaring that. Then minus the small radius. So the small radius, let me try to put this in a different color. Maybe a blue. That's being measured from this line up to the x-axis. Try to know that distance is 1. So pi times 1 squared. And my depth is dx because we sliced vertically. As far as my integral goes, it's going to be pi times the square root of x minus 1 squared minus pi, and then dx. And my bounds are the same as last time. You're going to start from 2, go up to 4. You can work through this if you want to, because you would actually square all this out, so square out this term using the FOIL method, find the antiderivatives, but what you end up getting is 40.512. I want to do another example, so we'll do example 2 here. My area is going to be bounded by y equals 2x plus 2, y equals x squared plus 2, and we're going to be rotating this about the x-axis. So just like we've been doing, I want to first figure out the area that we're looking at and then rotate it. So my area is going to be bounded by y equals 2x plus 2. That's a line going through this point here at 2. And then I have y equals x squared plus 2, which is a parabola that goes through this point. So here is my area, this little sliver right here. We're rotating this about the x-axis. So here's our line of rotation. So just imagine that's your mirror, and I'm going to flip this picture across that mirror and then connect these endpoints. It's kind of like a flower, almost. Hopefully you can kind of picture what that looks like. Take a slice out of the middle. So I'll make my slice in purple. There's my picture. Let's pull it out and let's figure out the volume of this slice. So again, because it has a hole in the middle, this is going to be pi times my big radius squared minus pi times my little radius squared, and then times the depth, which the depth is going to be delta x because we sliced it vertically. For my big radius, so let's look at this. My big radius is going from the x-axis to that top curve. So all the way up to the top curve. And since we're going from the x-axis, I don't need to worry about adding or subtracting or anything like that. So my big radius is going to be 2x plus 2. My small radius is going from the x-axis. It looks like up to that bottom curve. So that's x squared plus 2. And that's times delta x. So we will set this up. As far as bounds go, we'll worry about that in just a second. But it's going to be pi times 2x plus 2 squared minus pi times x squared plus 2 squared dx. Where do I start adding up slices? So going from left to right, I start adding up slices at 0, but I don't know what x value this is right here. So that's kind of a problem. To figure out that x value, I know it's where the two lines or the two curves intersect. So I could set up 2x plus 2 equals x squared plus 2. And this is a quadratic. So set it equal to 0. So that would be x squared minus 2x. Now let's factor this. I get x times x minus 2, so x equals 0 and x equals 2. So my other point of intersection was at 2. Okay, so now that we have this all set up, you can FOIL this part out, find your antiderivatives. I ended up getting 48 over 5 times pi. Alright, so I want to do one more example involving washers. So our area is going to be x equals negative y squared plus 4, x equals 0, y equals 0, y equals 2. And we're going to rotate this about the line y, not y, take that back, x equals 6. So first thing is let's draw this picture. This picture is a little bit different. So this curve x equals negative y squared plus 4. That's going to be a parabola that's been put on its side. And it's going to go through this point here at 4 on the x-axis. So here's my first curve. X equals 0, that's my y-axis. Y equals 0, that's my x-axis. And then y equals 2. I'm not sure we really need that portion, but there is our picture. So what we want to do is rotate that about the line x equals 6. Okay, so imagine that's your mirror, rotate it about that area. kind of connect your endpoints. So I don't know if you can tell what this one looks like. I mean, it's kind of that same picture we've been seeing where it's almost like a flower with a hole in the middle. But anyway, we're going to take a slice out of this. The only thing is we're not going to be slicing vertically. I don't think that makes sense. And when we drew our pictures, our circles are going horizontally. Right? This circle that I drew, that was horizontal. In the previous ones, all of our circles have been vertical like that. So that tells me I'm going to be slicing horizontally. So it's a little bit different. So let's slice this and pull that out and look at what happens. So I sliced it. There's my picture. It's definitely a washer. We're going to figure out the volume of that washer and then add them all up. So my volume of a slice. Same thing as before, because it has the hole in the middle, it's going to be pi r squared minus pi r squared times my little bit of depth. We'll fill that in just a second. My depth this time is delta y. And the reason it's delta y is because when I sliced horizontally, I hit the y-axis. So slicing horizontally means you're going to have everything in terms of y, which also means that this can only have y's in the equation. Before we only had x's because we had a delta x, but now we can only have y's. All right, so my big radius minus my small radius. We need to first figure out what are these two. So my big radius is being measured from this line here all the way out to the y-axis. So I have it in purple here. So there's my big radius, and you can see that big radius is the same for any slice that I would take, and it's just 6. Now let me try maybe in red. That small radius is going from this line back to the curve. So we're trying to figure out that distance. The distance that we know, so I know this distance, that's given to me by the curve x equals negative y squared plus 4. That's this little distance here. But I'm looking for the one that I just circled. So to figure out that distance, what I want to do is I'll do 6, then minus the negative y squared plus 4. And we are going to be squaring that. I think that's the wrong place for my square. There we go. So the reason is 6 measures from the y-axis all the way to x equals 6. This distance that I put the little block around, that's my curve. So to figure out the distance that's circled, I'm going to do 6 minus that curve. So my integral is going to be 36 pi minus pi times 6 minus negative y squared plus 4, and that's going to be squared, and then my dy at the end. As far as my bounds go, I need to figure out going from the bottom up towards the top. Where do you start adding up slices? So I start adding up slices where y is equal to 0, and then I stop adding up slices when y is equal to 2. So there's my integral. I'll let you actually work out that integral on your own, but that's how you would do one where we're slicing horizontally.